In this video, I want to have a look at how we can prove the pigeonhole principle. So we're going to do something called proof by contradiction. So we're going to assume that what we want to prove is actually not true, and then we're going to follow that through and show that that means there's a contradiction and it's not possible. So let's have a look at the two different versions. We're going to look at the basic version of the pigeonhole principle and then the more generalized one. So to start with, we want to prove that if there are n pigeonholes and n plus 1 pigeons to go in them, then at least one pigeonhole must hold 2 or more pigeons. So we're going to start by assuming that each pigeonhole contains at most 1 pigeon. So what we actually want to prove is that it holds 2 or more. The opposite of that is that it contains at most 1 pigeon. And we're going to prove that this can't be true. So suppose each one does contain at most 1 pigeon. So that then means that the total number of pigeons is at most n. So if we have n pigeonholes and there's at most 1 pigeon in each of those, then we can only have a maximum of n pigeons. So this then contradicts the fact that there are actually n plus 1 pigeons, which is what we started with. So because this can't be true because of that contradiction, this proves our statement that it must hold 2 or more pigeons. So we're going to use a similar method to prove the more generalized version. So the more generalized version is if n pigeons are sitting in k pigeonholes, where n is greater than k, so we have more pigeons than we do pigeonholes, then there is at least 1 pigeonhole with at least n divided by k pigeons in it. So we start by assuming the opposite then. We start by assuming that each pigeonhole contains less than n over k pigeons. What that means then that the total number of pigeons has to be less than k multiplied by n over k. So that's the number of pigeonholes, k, multiplied by the maximum number of pigeons in each hole was n over k, because we said there had to be less than that. So this is going to be the total number of pigeons has to be less than this number. If we simplify that, we can cancel out those k's and that just gives us n. So the total number of pigeons is less than n, but we said that we have n pigeons. So because this has told us that we have n, that means that that contradicts the fact that there are actually n pigeons, and hence our original statement must be true. So that's having a look at a proof of the pigeonhole principle.